Okay, so I wanted to start this video off where we left off with the last video and talk about a couple of things real quick. So again, if a number is written with an I, that's an imaginary unit. So when we're writing stuff or writing a square root of a negative number in the form bi, that's different than writing it as a complex number. Again, we're going to keep going here with stuff that's in the form of bi and write a few more of these in that format. So if I had something like the square root of 27 multiplied by the square root of negative 3, then I would multiply these together underneath and get the square root of negative 81. Well, again, this would simplify out to the square root of 81 times the square root of negative 1. And we know the square root of 81 is 9, and that the square root of negative 1 is I. So this would be written in the form bi. This would be 9i. Another example, if I had the square root of 8 times the square root of negative 2. Again, I'd multiply those together and get the square root of negative 16, but this would be written as excuse me, the square root of 16 times the square root of negative 1. Square root of 16 is 4, and the square root of negative 1 is I. So again, writing these in the form of bi. This next one here, if I had the square root of negative 64 multiplied by the square root of negative 1, the square root of negative 64 is 8i. Okay, and the square root of negative 1 is I. If I multiply those together, we get 8i squared. This value here of I squared is equal to the value of negative 1. So the answer here would be negative 8. Okay, so let's do one more. The square root of negative 72 over the square root of 2. If I were going to simplify that top, I could separate this out to the square root of 72 times the square root of negative 1. So that would be I on the outside, square root of 72. Instead, let's put this all under 1 hat now. And 72 divided by 2 is going to give me the square root of 36. I still have this I floating around out there. Square root of 36 is 6, so this would be 6i. So these are the answers that we would get if we're writing stuff that I'm using the quotient rule or the product rule, and I want to write it in the form of bi. So I just wanted to tag that on to this next lesson, which this next lesson, the goal here is to multiply and divide I'll just do a multiply right now, multiply complex numbers. So I'll show several different examples. Again, this is the multiply complex numbers. And that means we're going to be looking for them to be written in this form here. Again, A and B are real numbers. Okay, so how do we do this multiplication? Let's say that I have just negative 5i and I want to multiply this by a 3i. Well, negative 5 times 3 is a negative 15. I times I is I squared. So I follows the rules of exponents as if it's a variable. The value of I squared, again, is just -1. So we would have -15 multiplied by a -1, which would give us the end result here of 15. Okay, so that's like similar to a monomial times a monomial. But what if I had a single term here and I want to multiply that by 2 terms? Well, I'm going to distribute here because these are not like terms, so I can't add them together, but I can distribute. When I distribute, I'm going to get a -14 and an I, and I'm going to get a -6, and I times I is I squared. Again, this value of I squared is equal to -1, so this would be a -6 times a -1, which is a +6, and we write it in the form of the constant first, this +6 right here, and add or subtract the I. So again, written in this format here. So this would be distributing, okay, like we've done so many times before. We could also have foiling here. If we wanted to FOIL a couple of these, we could have something like 3 minus a 5i and a 2 plus an I. So when I FOIL, I'm going to do my firsts, 3 times 2, which is 6. My outers, which is going to give me a plus 3i. My inners, you can just treat I as if it's x. My inners are -10i, and my lasts is a -5i squared. So these are like terms right here, so I can combine them. So I would get 6 minus 7i. And anytime you have this I squared, this is where it's different than x, we need to actually substitute the value of -1. So -5 times a -1 is just a +5. And you can see here then that these can be combined for 11 minus 7i, again written in the constant and then imaginary unit. Okay, so this would be foiling. So again, we could just have single terms, we could have distribution, we could have foiling. We could also have special products that previously would have given us a perfect square trinomial. So something like 6 plus a 7i, but I want to square this. Well, remember that this means that I have a 2 of these. So I have a 6 plus a 7i and another 6 plus a 7i. Once I expand this, I'm going to go ahead and FOIL again. 6 times 6 would give me 36. 6 times 7 is going to give me a +42i. The inners here are going to be the same as the outers. That's what happens when you have the same 2 terms. I'll get another 42i. And then the last here are going to give me a 49i squared. Again, any time that you have this I squared here, it's going to be the value of -1. So I'm going to substitute the value of -1 there. These are like terms. So I'll have 36 plus an 84i and then minus a 49. When I combine these two together, I'll get a -13 plus 84i. Again, writing it here in this complex number form. So this -13 is a combination of -49 and 36 plus 84i. This is a special product. It's a complex number squared. And the last thing that we could do here is something that would look similar to difference of squares or multiply conjugates. And we've talked a lot about the idea of a conjugate. A conjugate would be same 2 terms. So if I had, x plus 5, then the conjugate would be x minus 5. And if I had the square root of 2 minus the square root of 7, then the conjugate would be the square root of 2 plus the square root of 7. And if I had 2 plus I, then the conjugate would be 2 minus I. Okay, so again, this idea of a conjugate keeps creeping up. We have it several times. So if I wanted to multiply conjugates together, let's see what ends up happening here. Okay, so again, we're going to use the FOIL method, just like we did here. We're going to do first times the first. 4 times 4 is going to be 16. Outers, going to be negative 30. Sorry, this is a plus here, conjugates of each other. Outers is going to be a positive 36i. Inners are going to be a negative 36i. And the lasts are going to give you a negative 81i squared. You'll note here that when you multiply by the conjugate, these are like terms and they sum to 0. Also notice that this I squared has a value of negative 1. So negative times a negative is going to give me a positive 81. So I will get 97 here when I multiply these complex conjugates together. Okay, so these are several examples of how to multiply complex numbers.